In this video we demonstrate 3 basic insulation resistance tests to the windings of this cast resin transformer. This particular one is a 1.25 MVA, 3.3 kV down to 690 volts, cast resin dry transformer. First we want to disconnect all the cabling on the HV and the LV sides. This side shows the 3.3 kV supply cable, and this is the LV side of the transformer where the LV cables have been disconnected. The connections we want to make are between the core of the transformer, the framework, and the high voltage connection onto 1U on the HV winding. We then link this across to 1V and 1W connections on the high voltage. Even though the windings of the transformer do create a short for this test, we also put the links in. Okay, test 1, we apply 5 kV VLF. That's very low frequency. 5 kV is the RMS value. We do this for 15 minutes and then we can record the capacitance and the resistance and the leakage current. So this sets the benchmark of any future tests with this installation as is. The second test we want to do is basically a repeat of the HV test. We want to short the LV windings together and apply this time 1 kV RMS VLF to the windings and check the resistance of the windings down to earth. Okay, we can generate the report from that now. And the final test, test 3, is we connect each of the LV windings down to earth. We then apply 5 kV VLF onto the high voltage side. So this is checking the resistance between the HV and the LV windings. Again, this is a benchmark test, so later on in future they can compare the results to make sure the transformer hasn't degraded. There's many tests you can do on a transformer. This is just 3 examples of the tests that can be performed for insulation resistance of the windings. If you ever find yourself investigating a transformer that has tripped on the HV side due to overcurrent or earth fault, these tests are a good place to start. Hope you found this of interest. If you did, please subscribe to the channel.